Hey everyone, today we're going to talk about polynomial graphs. But you might be wondering, what is a polynomial? So let me give you some examples and explain what it is. These three right here are examples of polynomials. You will notice that they all have powers of x. But only positive integer powers are allowed. So you're not allowed to have x to the negative 1/2 power, for example. You see 3x, that's really x to the 1 power. So I'll go ahead and I'll just show you that they're all positive integer powers of x. Also, you have terms that are added or subtracted from each other. That's part of a polynomial. The powers of x all have coefficients, and those can be any number that you want. In that first example, you see x squared, that's really 1x squared, so its coefficient is 1. So those are all the coefficients right there. And you are also allowed to add or subtract constant terms, meaning numbers that don't have any x associated with them. So those are polynomials, and we want to figure out what their graphs look like. Well, you probably realize that there are a ton of different options that you could make up for polynomials. So there's no way we're going to be able to come up with one graph for all possible polynomials, but we can give some ideas. Here are a couple options. These are actually both graphs of polynomials. You'll notice that they are continuous and smooth. What that means is that you can trace the graph without lifting your pencil. That's what continuous means, and smooth meaning there are no sharp corners. So graphs of any polynomial you can come up with will automatically be continuous and smooth. The next thing we're going to talk about are the zeros of these graphs. So a zero of a polynomial, or really of any graph, is where the graph hits the x-axis. As you can see on the graph, I've circled those locations. We will also discuss the turning points of a graph. That's pretty self-explanatory. It's where the graph changes direction, from increasing to decreasing or from decreasing to increasing. I also want to point out what happens at some of these zeros. You notice that some of them cross the x-axis, while one of them only touches the x-axis and bounces back off. Now you may be wondering why we're even talking about these, but I'm just giving you some familiarity with these terms so that we can graph one and see how it goes. This is the polynomial that I would like to graph. Now of course you could make a table, you could plug in numbers for x, get output numbers for y, but I'm actually going to teach you for polynomials a better way to graph it. And the first step in that would be actually to factor it. So I've factored it here for you, and I'll simplify it. Just combine those like terms there. And this is what that polynomial is. Exactly the same thing, just factored. And this is quite useful because when we go to graph this, we can actually read off what the zeros are going to be right away from the factored form. The zeros will come from when each factor individually will give you 0, meaning what number do you plug into x to make x plus 1 0? Well, that's -1. So boom, there's one of your zeros. And the other one, x equals 2, comes from that second factor. Now from the previous slide, we learned that zeros are where you cross the x-axis on a graph. Cross or touch. And now I'm going to show you how to determine whether you cross or touch the x-axis. And it all depends on the multiplicity of the factors. That's what it's called. Here's what you look for. Look at the exponents of each factor. If it's an odd exponent, it means it's going to cross the x-axis at that 0. If you have an even exponent, it means that at that 0 the graph will touch and bounce off the x-axis. So the factored form was quite useful. We were able to find the zeros and whether or not the graph crossed or touches and bounces off the x-axis at those points. So we know the zeros, we just need to connect these dots over on the graph. Here are the two options. One option looks like this. Remember, we have to cross at -1 and bounce off at 2. The other option would be this. Cross at -1, bounce off at 2. But which one of these will the actual graph look like? Here's how you figure that out. Plug in a random point, and what I mean is pick a number for x that isn't one of the zeros. Maybe like x is 0, and plug that into the function. That will tell you the corresponding y value. when x is 0, the y value is 4, which means it has to be above the x-axis at this spot, right there. So our only option is that the polynomial looks like this. Your turn. Graph this polynomial, but lucky for you, I factored it for you. So use the factorization here to find the zeros and whether you cross or bounce off the x-axis at those zeros. And then graph it.